What is polynomial? What is polynomial in one variable? Suppose let p of x equals to plus a to x square up to so on a n x power. This is the polynomial in one variable. This is called polynomial in one variable. Polynomial is also an algebraic expression. What is algebraic expression? Algebraic expression is the combination of variables and numerical constants with the help of the fundamental mathematics science like plus minus. Now what is the degree of the polynomial and what is the coefficients of the polynomial? The each numerical terms here a0, a1, a2, an are called the coefficients. The numerical terms a0, a1, a2 up to so on an are called coefficients. Are called numerical coefficients. Here coefficient of x is a1, coefficient of x square is a2 and also coefficient of x power n is a. Now degree. Now what is degree? We define degree. The highest power of the polynomial in the expansion. In the expansion, the highest power is n. So here degree is n. The highest power of the expression is called degree. Nice. Now, what is zero polynomial? Zero polynomial. The polynomial is in the type of 0 plus 0 into x, 0 into x square, up to so on 0 into x power. This type of polynomial is called zero polynomial. This type of polynomial is called zero polynomial. This must always equals to 0. And the degree of zero polynomial cannot be defined. The degree of the zero polynomial cannot be defined. Now, what is non-zero constant polynomial? Non-zero constant polynomial. Let me take the non-zero numbers like 6, 8, 10. Here, what is non-zero constant polynomial? The degree of the non-zero constant polynomial is 0. The degree is 0. Then the polynomial is said to be non-zero constant polynomial. Suppose let us take 6. The degree of the 6 is 0 because 6 can be written as 6 into 0. The highest power is 0, so the degree is 0. This is non-zero constant polynomial. Now, next examples. Find degree of given polynomials. First one, x power 5 minus x power 4 plus 3. Here the highest power is 5, so the degree is 5. Second one, 2 minus y square minus y cube plus 2y power 8. Here the highest degree is 8. So highest power is 8, so the degree is 8. Next one, 2 can be written as 2 into x power 0. So the degree is 0. Next one, exercise 2.1. Which of the following expressions are polynomials in one? Which of the following expressions are polynomials in one variable? Are polynomials in one variable? Which of the following are polynomials in one variable? Which are not? Four x square minus 3x plus 7. Yes, here only one variable x is included, and here degree is 2, and the degree is not in negative powers, so this is a polynomial in one variable. Second one, y square plus root 2. Sure, here only one variable y is included, and the degree is non-negative, so here this is also polynomial in one variable. Next one, 3 root t plus 2 root 2t. Here the t power is 1 by 2, which is rational number, so this is not a polynomial. 4 term y plus 2 by y. Here this is it, one variable included, but here power of y is negative. 2 by y can be written as 2 into y inverse. So this is not a polynomial. Last one, x power 10 plus y cube plus t power 50. This is a polynomial, but here three variables are included, x, y, t. Polynomial in three variables. In three variables. X power 10 plus y cube plus t power 50. It is a polynomial in three variables. Next one. Write the coefficients of x square in each of the following. First one. Here, coefficient of x square is 1. So 1. Second one. Here, coefficient of x square is 1. Yes, third one. Here, coefficient of x square is pi by 2. That's fourth one. Here, coefficient of x square is not, here x square term is not there. So, coefficient of x square is 0. Yes, third one. Give one example. Give one example. Each of binomial degree 35. Each of binomial degree 35. End of monomial degree 100. And monomial of degree 100. And monomial of degree 100. Now, the binomial means there are two terms in the expression. With degree 35, 6x to the power of 35 plus 12, x power 20. This is the binomial. Here two terms are there. Here the highest power of x is 35. So degree is 35. Next, monomial. In expression there is only one term, then the expression is called monomial. In the expression only one term is there, 267 into x power 100. Here degree is 100. Next one. Write degree of each of the following form. Right? Degree of each of the following form. First one. 5x cube plus 4x square plus 7x. Here highest power is 3. So the degree of the polynomial is 3. Second one. Here highest power is 2. So degree is 2. Third one. Here highest power is 1. So degree is 1. Here highest power 3 is a constant polynomial. So it will give a degree 0. Next, classify the given polynomials. Classify the following as linear, quadratic and cubic polynomials. Quadratic and cubic polynomials. First one, x square plus 7x. X square plus x. This is degree 2, so this is quadratic. Next, x minus x. We asked for 3, so degree 3, so this is cubic polynomial. Next one, y plus y square plus 4. Here degree 2, so this is quadratic. Fourth one, 1 plus x. Here next degree is 1, so this is linear polynomial. Fifth one, 3d. Here also degree 1, so this is linear polynomial. Next one, r square. Here degree 2, so this is quadratic. This is a polynomial degree 2, so this is a quadratic polynomial. Zeros of a polynomial. Now, what is zeros of a polynomial? In the polynomial, if we place any number in place of x, then that result will give 0, then that number is the zero of the polynomial. Now, suppose we take one example. Consider the polynomial p of x equals to x square minus 4. Here, consider the polynomial p of x equal to x square minus 4. Now, we replace x by 2. We replace x by 2. We will get p of 2 equals to 2 square minus 4, which is equal to 4 minus 4, which is equal to 0. Now, which will give the value 0. Then here x square minus 4 is the polynomial. 2 is the zero of the polynomial. 2 is the zero of the polynomial x square minus 4. 2 is the zero of the polynomial x square minus 4. Next, find the value of each of the following polynomials. First one, p of x equals to 5x square minus 3x plus 7. Here x equals to 1. Now we have to find the value for the polynomial p of x equals to 5x square minus 3x plus 7. At x equal to 1. We replace x by 1. Then we get p of 1 equals to 5 into 1 square minus 3 into 1 plus 7. Here 5 into 1 square is 1 square value is 1. So 5 into 1 is 5. 5 minus 3 plus 7. Here 5 minus 3 is 2. 2 plus 7 is 9. Here the value of the polynomial x equal to 1 is 9. The value of the polynomial at x equal to 1 is 9. Next one, q of y equals to 3y square minus 4y plus root 11 at y equal to 2. At y equal to 2, we have to find the value of the polynomial. Now, q of 2 equals to 3 into 2 square minus 4 into 2 plus root 11. Here 2 square value is 4. Now 3 4 3 into 4 minus 4. 3 4 12. Minus 4 into 2 is 8 plus root 2. Here 12 minus 8 is 4. 4 plus 12. Here we replace q of y. Now we replace y by 2, and we will get into 2 square minus 4 into 2 plus root 11. Here 2 square value 4, 4 3 is 4 into 2 is 8, root 11. 12 minus 8 is 4. Next one, p of 2 equals to 4 into t power 4 plus 5t cube minus t square plus 6. Yet p equals to 8. Now p of a equals to 4 into a power 4 plus 5a cube minus a square plus 6. This is the value of the polynomial p equals to a. Next one, check whether minus 2 and 2 are the zeros of the polynomial. Minus 2 and 2 are the zeros of the polynomial x plus 2. Now, first we take the polynomial p of x. Let p of x equals to x plus 2. Now, we have to find the value at x equal to minus 2. Now, p of minus 2 equals to, we replace x by minus 2, then we will get minus 2 plus 2 is 0. Now, we replace x by 2, we will get 2 plus 2 is 4. Now, here p of minus 2 will use the value 0, p of 2 will use the value 4. So, here p of 2 is the 0 of the polynomial x plus 2. Because the value of the polynomial x equal to minus 2 is 0. So, therefore, minus 2 is the 0 of the polynomial x plus 2. Next one, find the 0 of the polynomial. Find the 0 of the polynomial p of x equal to 2x plus 1. P of x equals to 2x plus 1. The value of the polynomial is 0. Then the value of the polynomial is 0. If x equal to something, then this is the 0 of the polynomial. Now we have equating p of x equals to 0. Then 2x plus 1 equals to 0. 2x equals to minus 1, x equals to minus 1 by 2. Here minus 1 by 2 is the 0 of the polynomial for 2x plus 1. Now we equate 2x plus 1 to 0. Now here minus 1 is transferred to this side, minus 1 is converted, plus 1 is converted to minus 1. Here 2x equal to minus 1. Here 2x equals to minus 1, x equal to minus 1 by 2. Here 2 is multiplied here, and this side 2 is divided. Next one, verify whether 2 and 0 are zeros of the polynomial x square minus 2x, x square minus 2x. Verify whether 2 and 0 are the zeros of the polynomial x square minus 2x. Let p of x equals to x square minus 2x. Let p of x equals to x square minus 2x. Now, I have to verify 2 is the 0 of the polynomial. First we substitute 2 in the place of x. We will get 2 square minus 2 into 2. That means 4 minus 4, which is equals to 0. The value of the polynomial x equal to 2 is 0. Therefore, 2 is the 0 of the polynomial. And we substitute 0. 0 square minus 2 into 0, which is equals to 0 minus 0, which will give 0. Therefore, the value of the polynomial x equals to 0 is 0. So, therefore, here both 2 and 0 are the zeros of the polynomial x square minus 2x. Therefore, both 2 and 0 are zeros of the polynomial x square minus 2x. X square minus 2x. Next one, exercise 2.2. Now, first one, find the value of the polynomial. Find the value of the polynomial. Find the value of the polynomial. 5x minus 4x square plus 3. 5x minus 4x square plus 3 at x. First one, x equals to 0. And second one, x equal to minus 1. And the x equal to 2. Now, first, let p of x equals to x 5x minus 4x square. Here given that polynomial is 5x minus 4x square plus 3. We have to find the value of the polynomial x equal to 0, x equal to minus 1 and x equal to 2. Let p of x equal to 5x minus 4x square plus 3. Now we substitute x equals to 0, then 5 into 0 minus 4 into 0 plus 3, which will equals to 3. Next one, p of minus 1, which is equals to 5 into minus 1 minus 4 into minus 1 square plus 3. Here 5 into minus 1 is minus 4. Here minus 1 square is plus 1, plus 1 into minus 4 is minus 4 plus 3. Here minus 5 minus 4 is minus 9, minus 9 plus 3 is minus 6. Therefore, the value of the polynomial at x equal to minus 1 is minus 6. Next, at x equal to 2, 5 into 2 minus 4 into 2 square plus 3. Now, 5 into 2 is 10 minus 2 square is 4, 4 into 4 is 16 plus 3. Now, 10 plus 3 is 13, 13 minus 16 is minus 3. Therefore, the value of the polynomial at x equal to 2 is minus 3 and the value of the polynomial at x equal to minus 1 is minus 6. The value of the polynomial at x equals to 0 is 3. Next one. Find p of 0, p of 1 and p of 2 for each of the following polynomials. First one. P of y equals to y square minus y plus 1. Y square minus y plus 1. You have to find the value at p of 0 and 1. Now, at x equals to 0. At x equals to 0, p of 0, we replace y by 0. Therefore, 0 square minus 0 plus 1, which is equals to 0 square is 0 minus 0 plus 1, which is equals to 1. 0 minus 0 is 0, 0 plus 1 is 1. Next, at x equals to 1. Now we replace y by 1, we will get 1 square minus 1 plus 1. Here 1 square is 1, 1 minus plus 1 is 1 minus 1 is 0, 0 plus 1 is 1. Here 1 minus 1 is 0, 0 plus 1 is 1. Next, we have 2. 2 square minus 2 plus 1. 2 square is 4. Here 4 minus 2 is 2. 2 plus 1 is 3. The value of the polynomial at x equals to 0 is 1. Then y equals to 1 is 2. Then y equals to 2 is 3. Next one. P of t equals to 2 plus t plus 2t square minus p cube. Now, at t equals to 0, 2 plus 0 plus 2 into 0 square minus 0 cube. Now 2 plus 0 plus 0 plus 0 which is equals to 2. Here in the place of t we replace by 0. We replace t by 0. Therefore 2 plus 0 plus 2 into 0 square minus 0. Here 0 plus 0 plus 0. 2 plus 0 plus 0 is 2. Next p of 1. In the place of p we replace 1. Therefore 2 plus 1 plus 2 minus 1. Here minus 1 plus 1 gets cancelled. 2 plus 2 is 4. Next one p of 2. Therefore 2 plus 2 plus 2 into 2 square minus 2 cube. Therefore 2 plus 2. There 2 square value is 4. 4 into 2 is 8. 2 cube value is 8. Minus 8 plus 8 gets cancelled. 2 plus 2 is 4. The value of the polynomial at t equals to 0 is 2. At t equals to 1 is 4. At t equals to 2 is 4. Next one. P of x equals to x cube. Now at x equals to 0. 0 cube is 0. And at x equals to 1. P of 1 equals to 1 cube which is equals to 1. Now at x equals to 2. P of 2 equals to 2 cube which is equals to 8. Which is equals to 8. The value of the polynomial at x equals to 0 is 0. At x equals to 1 is 1. At x equals to 2 is 8. Next one. X minus 1 into x plus 1. Now we replace x by 1. Sorry, x by 0. Now 0 minus 1 into 0 plus 1. Here 0 minus 1 is minus 1. 0 plus 1 is 1. Minus 1 into plus 1 is minus 1. Next we replace x by 1. 1 minus 1 into 1 plus 1 which is equals to 0 into 2 which is equals to 0. Next we replace x by 2 which is equals to 2 minus 1 into 2 plus 1. 2 minus 1 is 1. 2 plus 1 is 3 which is equals to 3. The value of the polynomial at x equals to 0 is, here now we replace x by 0. 0 minus 1 into 0 plus 1. Minus 1 into plus 1 is minus 1. And also we replace x by 1. 1 minus 1 is 0. 0 into anything is 0. Next at x equal to 2 is 2 minus 1 into 2 plus 1. 2 minus 1 is 1 and 2 plus 1 is 3. 1 into 3 is 3. Therefore the value of the polynomial at x equals to 0. X equal to 0 is minus 1 and x equal to 1 is 0 and x equal to 2 is 3. The following are zeros of the polynomial indicated against them. Verify whether the following are the zeros of the polynomial indicated against them. First one, p of x equals to 3x plus 1 at x equals to minus 1 by 3 at x equals to minus 1 by 3. Now we replace x by minus 1 by 3. Now 3 gets cancelled. Minus 1 plus 1 is 0. Minus 1 plus 1 is 0. Therefore minus 1 by 3 is the zero of the polynomial p of x greater plus 1. Next second one. P of x equals to 5x minus 5 at x equals to 4 by 5. Now we replace x by 4 by 5. We will get 5 into 4 by 5 minus 5. 5 gets cancelled which is equals to 4 minus 5 which is not equals to 0. Therefore 4 by 5 is not a zero of polynomial p of x at x equal to 4. P of x equals to x square minus 1 comma x equals to 1 comma minus x by 1 we will get 1 square minus 1. Here 1 square value is 1. 1 minus 1 equals to 0. Now we replace x by minus 1 minus 1 square minus 1. Minus 1 square value is 1. 1 minus 1 is 0. Therefore, both 1 and minus 1 number they are the polynomial p of x square minus 1. Next, fourth one, p of x equals to x minus 1, sorry, x plus 1 into x minus 2. At x equals to minus 1 comma 2. Now, we replace x by minus 1. Therefore, p of minus 1 equals to minus 1 plus 1 into x 1 minus 2, which is equals to 0 into minus 1, which is equals to 0. Now we replace x by 2, which is equals to 2 plus 1 into 2 minus 2, which is equal to 3 into 0, 0. Now we replace x by minus 1, we will get minus 1 plus 1 is 0, 0 is 0. And we replace x by 2, therefore 2 plus 1 is 3, 2 minus 2 is 0, 0 into anything is 0. Therefore minus 1 and 2 are the zeros of the polynomial p of x equals to x plus 1 into x minus 2. P of x equals to x square at x equals to 0. Now we replace x by 0, which is equals to 0 square equals to 0. That 0 is the zero of the polynomial p of x equals to x square. Next one, p of x equals to lx plus m at x equals to minus m by n. So x equals to minus m by n. Now we replace x by minus m by n. We will get l into minus m by n plus m. L gets cancelled. Minus m plus m is 0. Therefore, minus m by l is the zero of the polynomial p of x lx plus m. Next one, p of x equals to 3x square minus 1 at x equals to minus 1 by root 3 comma plus 1 by root 3. Super. Now we substitute minus 1 by root 3 in the place of x, we will get 3 into minus 1 by root 3 whole square minus 3 into 1 by 3 minus 1. 3 gets cancelled. 1 minus 1 is 0. Therefore, 0 is minus 1 by root 3 is the zero of the polynomial for p of x equals to 3x square minus 3 of 2 by root 3. 3 into 2 by root 3 whole square minus 1. Here 3 into 4 by 3 minus 1. 3 gets cancelled. 4 minus 3 is 3. Therefore, here only minus 1 by root 3 is the zero of the polynomial p of x equals to 3x square minus 1. Next one. Find the zero of the polynomial in each of the following cases. Find the zero of the polynomial in each of the following cases. In each of the following cases. First one, p of x equals to x plus 5. Now we equate p of x equals to 0. Therefore, x plus 5 equals to 0. Plus 5 is transferred to this side and plus 5 is converted to minus 5. Therefore, minus 5 is the zero of the polynomial p of x equals to x plus 5. Next one, p of x equals to x minus 5. Now we equate p of x equals to 0. Now p of x equals to 0. Therefore, x minus 5 equals to 0. Now minus 5 is transferred to this side. Therefore, x equals to plus. Next paragraph, p of x equals to 2x plus 5. Now we equate p of x to 0. Therefore, 2x plus 5 equals to 0. 2x equals to minus 5 is transferred to this side, minus 5 converted to, sorry, 5 converted to minus 5. Therefore, x equals to minus 5x. Here, p of x equals to 0. Therefore, p of x value is 2x plus, therefore 2x plus 5 is 0. Minus 5 is transferred to this side, minus 5 converted, plus 5 is transferred to that side, converted to minus 5, and 2x equals to minus 5. Here 2 is multiplied and 2 is transferred to this side, therefore 2 is divided, therefore 2x equals to minus 5 by 2. P of x equals to 3x minus 2. Therefore, now we equate p of x to 0, therefore 3x minus 2 equals to 0. Now minus 2 is transferred to this side, 3x equals to plus 2, x equals to 2 by 3. Here 3x minus 2 is 0, therefore minus is transferred to this side, 3x equals to 2, x equals to 2 by 3. Next one, p of x equals to 3x. Now 3x equals to 0, p of x is 0, therefore 3x equals to 0. That means that equals to x equals to 0. That equals to x is 0. Next one, p of x equals to ax. Now p of x equals to ax. Now px is equals to 0, therefore ax equals to 0. That means x equals to 0. Here p of x equals to ax. Now px is 0, therefore ax equals to 0. Now ax is 0, therefore x equals to 0. Next, p of x equals to tx plus d, where c not equals to 0, where c not equals to 0. Now here p of x equals to x, therefore p of x equals to 0. Therefore p of x equals to 0. Therefore cx plus d equals to 0. X equals to plus d is transferred to that side, and plus d converted to minus d. X equals to, now minus d c. Here c is multiplied, c is transferred to that side, then then x equals to minus d by c. X equals to minus d by c is the year of the polynomial cx plus